Hello, sir.
Yeah, hello, let's say I'm audible.
Yes, sir.
Alright, let's come to the point. In the last class yesterday, which topic we discussed? A simple note. In the last class, okay. So yeah, if you could remember, in the last class we talked about some equations, right? And we discussed how your values stays in the different quadrant, right? So that is all we discussed in the previous session. Okay, all right. So for the today's discussion, we can go further from that topic. Example, if I just go with some equation. Let's say, can you see the screen? I think I have shared
No, sir.
this. Okay, fine. Can you see this screen now?
Yes, sir.
Okay, good, so okay. So there's a written equation in the picture. The equation is this. Okay. So here you're given one equation which is 1 plus 4x minus x squared, okay? Which is like 9 of secant square y plus 4 times of cosecant mm, square y. This is and half of it. And this is given to, okay? You need to compute, so let's say, can you solve these kind of problems? Are you confident in solving problems related to these kind of statements and all?
No, sir.
You have doubts, right? Okay, so let's solve it. Okay, should I give the solution or you want to try?
Sir, you give the solution.
Okay, let's get the solution. Look, if you look at this equation, what is the main important part to calculate? Okay, let's rewrite this equation once. 1 plus 4x minus x square is equals to this, right? 9 secant cosecant y under it. Okay? The main important part which comes into your mind is, can we write this equation in another format? Because if you see, this equation is a quadratic equation in itself, right? So let's look at this one. Let's try to write in another. What is that? Let's take it once. Or you can say, let's solve LHS. Solve left hand side. So we have left hand side this, right? So how you can write it? So this is the thing, right? Uh, can we write it in other format? Yes, actually we can write it. What is that format? It's not a perfect square. You can't form any equation which is a perfect square number. Okay. First of all, what we can think of is, if you could remember in one way, what is to represent any quadratic equation in form of something square plus c. Okay, I explained you one method in the last class. It you may remember or not. Let's discuss that again. I can see that this minus this x is having a negative sign. Okay, let's remove this negative. Okay, we have written in this x square minus 4x minus 1. You can see this x has positive sign. Okay, makes sense. It has a square. So I can simply say I can write something x plus something square. Okay, because when you open it, it becomes something like x square plus b square plus 2ab. Okay, something. So here I have x b. Okay, so I have actually x square. I have anything else I don't know. But if you see carefully, I have a coefficient of x also in this. So I can relate this 4 with 2 times of b. So here I had minus 4. Okay, so you can actually make 2b is equals to minus 4, b is equals to minus 2. Clear? So instead of this, you got a value as b. Something like negative x minus b square. Is it the complete thing? The answer is no. Okay. The answer is very no. Why? Because this is not equals to this one. Yes. We have to add something c which will make the whole equation correct. So what you can do is plus add something c is equals to this thing. So here if you see in this particular problem, actually you have to do this. So minus x minus 2 whole square. What is that extra c part? So if you just open it, you could remember x square plus 4 minus 2x. Sorry, this comes out as 4 times of x. Okay, this is what you are going to get if you open plus c. This whole thing should be equals to this thing. So if you see, you have x square, you have minus 4 also, but you don't have minus 1. It means 4 plus c should come out equals to minus 1. So c should come out as minus 5. Okay. Simply write it like this. You have to make the equations like this. Understood? That's how you can come up for these kind of different equations. So yeah, let me know if you are clear with this thing. This is small part. Yeah, let's say, are you clear with this thing? This is small part.
Yes.
How to make kind of equations like this. So we can simply say we have finally made this equation into another format. What is that format? Something like negative is as is this x minus 2 whole square minus 5 3 quarter. Okay? Like this, and if you rewrite this, open it in another form, it will become x 5 minus 2 something like this. We are getting okay. This equation is written in this form. I hope this is fine, clear. Okay. Let's rewrite this equation. Let's talk about RHS. RHS is given as 9 times of secant square y plus 4 times of cos secant square y. Okay, anything else is left? No. Now, how I should think of it solving these kind of equation? You see, I have converted this equation into two format, right? I wanted to convert this into also some relation. Understood? I wanted to convert this thing also into some kind of relations. How I can do that? Do I have any way by using that I can convert it? I may try for this or I may not be trying for this. Okay. This is a thing I can actually do. So what we can further do is before moving to Lassia, do you know one relation we have between a tan theta and cos theta? The relation is um, tan square theta actually it's 1 plus tan square theta is equals to secant square theta. I think you might not be aware of this equation.
No, sir.
Okay. Sorry, I was Rashka told you earlier this part. Okay. So what do you can do? For now, just assume you know this equation and you can go ahead with it. Okay. Just you can think of it once if you could. So you might extend this thing and put this equation over here. So this will actually come it out as the sequence verifier. So it will come out as 9 plus 9 times of tan square theta plus we are left with 4 times of cosecant square. Sorry, here it should be y. This is y plus 4 times of cosecant square y. This is what you are getting right now. And anything else what you could remember we can actually do? Can you think of it something? Yes, we can do it. What is that? 1 plus cot square theta. That comes out as cos square theta, something similar to this. So we can extend it over here. That means 13 plus 9 tan, sorry, square y plus this thing substituted by this thing for cot square theta. Something like this you can actually make. Okay. Now again, if you see this is the perfect square, if you see this is the perfect square, so I will try to convert this whole equation into 3 tan of y plus 2 cot of y whole square. This is what I'm trying to I'm trying to do. Okay. If I do that, I'll be getting some equation. What is that? Something like okay. This part I'll get. This part I'll get plus 2 times of 3 into 2. That comes as 12. Oh yeah. 3, 2, 6, 2, 12. Yes. 3 to sorry, 6 to 6. I did not remember. 6 and this 10 5 multiplied by 40. This I would be getting extra part, okay? Because it is not a part of equation. So you can do one thing, just add 12, okay, and minus 12. If you do this, 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 and this, the whole thing result is something called uh, it's a part of equation, right? It's some part of your equation. Sorry, here it should be. Okay, we are doing that in this way. Yeah, I think that's fine. We can actually go ahead and complete it in this into this format by saying it 3 times of tan of y. Okay, you needed something like 3, 2, 6, and 12. So you can actually make it like this. Do you know why we got this one extra from here?
No, sir.
Okay, let's say before moving, just let me know which step you are having out.
Sir,
If you think like this problem is ambiguity, we can have actually leave it. It's actually long. Okay,
sir, it's very long. The process is lengthy.
always lengthy, right? Okay. Okay, let's do one thing. We'll come back to this problem after solving some kind of problems. Okay, which might be much better instead of doing directly to this problem. I'll actually reload it once. Okay, so let's do that. Okay, let's try another problem. Very simple equation. Okay, what is that equation? You are given tan theta plus secant theta. Okay, this is equals to 1.5. Can we try to calculate just tan theta? Can we calculate just sine theta? Can we calculate just secant theta? These three things, okay? These three things. This is not a very big equation kind of thing. It's a simple thing, okay? So, do you want to give it a try, or I should explain it once?
Sir, I'll
Just
try.
okay, just try it. Okay? Look, a very simple idea is that even if you get any of them, you can get the rest of them. Okay, we have already tried this kind of thing. So you can just try to convert it into one form. Okay, I don't even want all. You may think of using this equation. You may. Okay, I'm not suggesting you to use it, but you may think of doing it. You may try if it works. Okay. Look, I'll give you one more hint. Okay, we can try one more problem, and you can try it as homework. Okay, it will take time. So look, let's see which step you have reached so far. Wait, I got this. Hello, Lisa.
Yes, sir. Hello, sir.
Yeah, which step you have reached?
Sir, I'm trying, sir, but I'm not getting it.
Okay, okay, so look, should I give you one hint? Okay, just hint I'm going to give. You can try it once. If you're not able to get it, I'll explain it. Okay. So look, whenever you get these kind of problem, look at this. You have got something 1.5. Do you think it is what I can say? Can you solve it? No. What you can do, always try to convert this problem. What you can say that you can actually make it something like 3 by 2. Why I'm saying 3 by 2? Try to remove the decimal. Okay, this is 1.5. So it's better option for you to remove the decimal. What are two options? Simply multiply both sides with 2. So this becomes 2 and this becomes 3. Okay, that is what you can do. Now, uh, you can actually rewrite this equation as this. Okay, because we wanted to solve this thing separate. So from here, I'll give you two options to try. These two options will take you to two different problems. Okay, if you try that, you will get better understanding of problem. So if you see, I have given this equation, right? So what you can actually do it, instead of secant theta, what you can write, if you see carefully, secant theta can be written in the form of 1 plus tan square theta and under root, right? So from here actually you can go something like this, tan theta plus 1 plus tan square theta and under root. This is equals to 3 by 2. Also, if you take this to other side, it will become 1 plus tan square theta and under root is equals to 3 by 2 minus tan theta. Okay. Why I am saying this? Now what happened? You have two options. Either square this way, but if you do that, you will be taking a root with you and continuing with it, which will give you unnecessarily a bigger equation. Okay. Instead, what you can do, now if you do the square both sides, what will happen if you see this comes into the square, right? And this square root will get removed. Okay. So how you can actually do it? It will something like 1 plus tan square theta is equals to 3 by 2 square plus tan, okay, sorry, this is tan square theta minus 2236, 3 times of tan theta. If you see carefully, can I say that we have got one, okay, yes. Yeah, actually, we have got something in the format of square. You can actually try it using, like, you have got an equation which you can try. If you see carefully, this get cancelled, right? What you're left with 1 is equals to 3 by this. If you open it, it will become 9 by 4 minus 3 times of tan of theta. Can we solve it further? Yes, you can take it this side and you'll get the answer, right? Tan theta is
Yes,
equals
sir.
to 3 times of tan theta is equals to this go this side 4 by 5 by 12, 4 I can see, and tan theta comes out as 5 by 12. Is that clear?
Yes, sir.
So, and another way was, instead of changing this secant theta, change that tan theta. What is that tan theta? How you can write? Tan theta can be written as secant square theta minus 1 under root. Okay. So either way, try to convert it into one form which gives you the answer. Now, if you see, you know the tan theta, and we have already seen, if you could remember when we started the class, we used to get the value of sine theta, then we used to calculate the rest of the other forms, right? Cos, tan and all. The same thing you can do and calculate sine secant for this tan theta. You know, if you get the secant theta, sine basically tan theta, you can calculate sine, you can calculate cos, you can calculate secant, and every kind of different ratios you can actually come up. Is that clear?
Okay, sir.
Okay. Are you clear with this method of solving these kind of problems?
Yes, sir. But you told that tan theta equals to root 6 square theta minus 1, no, sir.
Wait, wait. Which one? I told
Tan theta equals to root over 6 square theta minus 1.
this one, right?
Yes, sir. Why did
Yeah.
root come, sir?
Okay, root comes. Look at this now. Look at this equation. Here, I'll just remove it once and take it again. Select it. How we have written this equation? This is a formula. Okay, this is an identity, not formula. Something you can call it as an identity. Okay, can I say take this one to other side? Yes, I can actually. So tan theta comes out as square secant square theta minus n. Now put this because of this is that, so put under root both sides. The moment you put under root, sorry, it will become tan square theta under root secant square theta minus 1 under root. Because you can't actually solve it directly, but yes, here power is 2, here power is half because simple under root is of half the power. So this becomes tan theta secant square theta minus. Is that clear?
Yes, sir.
Sorry. Yes. Okay. Yes. So look, I solved by putting secant theta is equals to this way. I will suggest you to try by putting this into this way. And why I'm saying this, if you do this, you'll get answer of secant theta. Does it mean that if I get this equation to get the secant theta, I have to do the complete step? I'll say no. Why I'm telling you, if you see carefully, you will be getting another way of solving it. Understood? So from here, because I have already told you tan theta you are given, so you can assume it to be perpendicular. It can be height. So this is perpendicular, this is height. You can directly get sine theta. What is that? Perpendicular is pi divided by what is hypotenuse? You don't actually this is okay. Hypotenuse you don't know, but a square, h square, and under root. So that comes out as 5 square, 12 square, under root gives you 5 by 13. Okay, that's how you can think of it. So again, you can directly get the cos. What is that? B by h. Already you have h, you already have b. So 12 by 13. What is secant theta? The reverse of this 13 by 12.
13 by
Understood?
12.
So you got the, yeah, you got one thing, you can get the rest of the things. Okay.
Okay.
So all right. Today I won't be sharing any PPT or something because we spent unnecessary time in other problems, right? And we finally solved this one in one day. Look, I'll give you one more problem. Okay, use it as a homework. Okay.
Okay.
Mm, okay. Yeah. This is simple. Okay. So you are given cosecant theta minus secant theta. Okay, which is equals to sorry, which is equals to sine theta and okay. Another is and secant secant theta minus, you can write it as cos theta okay, is equals to, what you need to do is you have to eliminate, remove theta. What does this mean? How you can actually remove it? You need to form an equation in such a way, okay, which will give you an identity based on m and n. It might be, look, it can be anything. What it can be like n square plus n square is equals to something. Basically, your final equation should include m and n, but it should not include theta. When I'm saying theta, it is very evident that it should not include sine, cos, theta, any trigonometric ratio, because any trigonometric ratio, any trigonometric ratio will directly come up with a theta itself, right? Is that clear?
Yes.
You have to combine them in such a way, this m into n in such a way that you get an identity, but without the existence of theta in that particular equation. Clear?
Yes, sir.
Okay. Yeah. So you can just note it once.
I noted it, sir.
Noted, right? If in the next class I forget to explain, like I directly ask you about this problem, you can remind me. Okay, I'll get the solution if you don't able to make it. So yeah, let's say that's all for this discussion.
O-
We can end it by here. If you have any query which
No doubt, sir.
No doubt, right? All right, let's say so we can end the session. That's good.